In a former video about the new Raphson method, I showed you that the function actually was going to converge no matter what, because I used 2 and it was actually going to converge to 2 because it was the point in which the parabola was passing through. I used 2.33 and eventually I got 2 back again. But you know what you were thinking? You were thinking, hold on a second, you used 2.33, so 0.33 is actually, very damn close to 2. So showing that in 2 steps, you were actually getting 2 back, which is the point in which is passing, doesn't actually really look like magic. It looks like cheating. And uh, and I was like, okay, fair enough. I'm gonna use the very same function, f of x equal to x squared minus x minus 2 equal to 0. And this time I'm going to use as x0 negative 0.7, and I'm going to show you that it's still going to converge to 2. Well, not actually precisely to 2 because it's going to take a little bit longer, but it's still going to converge to a value that is pretty damn close to 2. So let me write it again, the formula for, as I always do, because it's important, it helps you memorize it. So for the Newton-Raphson method, we have xn plus 1 equal to xn minus f of xn over f prime of xn. So basically we write back our function, which is x squared minus x minus 2. We take the first derivative, which is 2x minus 1, and we said that our starting point is going to be this time negative 0.7. So there we go. We start with x1. So xn is actually going to be negative 0.7, so negative 0.7 minus, then we plug negative 0.7 back into our original function. So basically negative 0.7 squared minus 0.7 minus 2, everything over, and then we plug negative 0.7 back into our first derivative. So 2 times negative 0.7 minus 1, and this is actually going to give us negative 0.7 minus 0.49 plus 0.7 minus 2, everything over 1.4 minus 1. So this gives us negative 0.7 minus negative 0.81 over 0.4. So what do I get? Well, I actually get negative 0.7 plus 0.81 over 0.4, which gives me, 0.4, so negative 0.28 plus 0.81, so 0.53 over 0.4, so 1.325. All right. So we started with a negative value, but we already got a positive value, so 1.325, which is, fairly good. But let's go on and go to x2. X2 is actually going to be 1.325 minus, and then we plug 1.325 back into the function, so 1.325 squared minus 1.325 minus 2 over, and we plug 1.325 into the first derivative. So 2 times 1.325 minus 1. So we got 1.325 minus 1.755 minus 1.325 minus 2, everything over 2.65 minus 2. And we actually get, we got 1.325 minus negative 1.57 over 1.65. So we get 1.325 plus 1.57 over 1.65, and so we get 2.186 plus 1.57, everything over 1.65. So this is actually 3.756 over 1.65, which is roughly 2.27. So you can basically see that we already got 2.27, which is slightly overshot because the value we are looking for is 2, but 2.27 after only 2 steps, starting from negative 0.7, which is far from it. It's actually pretty remarkable. So this actually shows you that if things go in the right direction, let's say, and if things go the way they should, this method is actually going to converge very fast. But there are many things that can go wrong, and this method may not converge, so be careful. But if things go the way they should, this method is really going to converge very fast.